An improper integral is just an integral that you first have to approximate and then take a limit to turn your approximation into a perfect answer. So here we are trying to determine if the area underneath the curve natural log of x divided by x squared is finite. So we want to figure out if this function here, which is graphed here, has a finite amount of area underneath it. So even though it's never going to hit your x-axis, it might decay fast enough to where this area is a real number, right, and not infinite. So the way that we're going to do this is we're going to integrate from 1 to infinity our function. Right, that's what we're trying to do. We're trying to figure out the area underneath this function from 1 to infinity. And we will do this by integrating up to some arbitrary constant. So let's maybe put b right here for visual purposes. So what we're going to do is integrate from 1 to b our function. And then this will give us the area, and we will finally take a limit as b goes to positive infinity. And if that limit converges, if we get a real number, then we say that the integral converges. So let's see if we get a real number from this. The limit is going to be the very last thing that I take. I first have to give myself an expression for the area underneath this function from 1 to b. So I need to find an antiderivative and evaluate it at the bounds. So this problem, if you want to pause it for a moment and think about what you're going to do, this problem is an integration by parts problem. So if I choose to differentiate the natural log as 1 over x dx, meaning that we will integrate x to the minus 2, or 1 over x squared, as minus x to the minus 1, then integration by parts tells me that this integral can be written as u times v, so natural log of x, times a minus x to the minus 1, evaluated from 1 to b. So uv minus integral v du. So that's just an application of integration by parts. So let's clean this up a little bit. Eventually, we will send b to infinity. Here we have minus natural log x over x evaluated between 1 and b. And this second integral is now the integral of x to the minus 2, which will integrate as minus x to the minus 1. So we found antiderivatives. And if we evaluate those antiderivatives at the upper bound, b, and at the lower bound, 1, we have minus natural log b over b plus natural log 1 over 1 minus b to the minus 1 plus 1. Okay, so if we are able to take b to infinity and get a real number out of this, we say that the integral converges and the area is finite. So what's going to happen as b gets larger and larger? By L'Hopital's rule, or by convergence arguments, the denominator of this first fraction grows faster than the denominator of grows faster than the numerator of that fraction. This term will drop down to 0. This term is just equivalently equal to 0. And this term, you can rewrite it as 1 over b. So as b gets larger and larger, it will decay to 0. So you really just end up with this 1 right there. So the limit as b goes to infinity of this integral is 1. So this area is finite and is equal to 1, so the integral converges.